Good morning and welcome to our regular Access Machinery Saturday live stream. Today I'm joined by Alex Kimball, who's here, who works with metallics all the time, who's been a long-time avid user of it and a long-time supporter. For those who know, and for those who don't know, Access Machinery is a dealer of durma equipment. Durma, of course, is a Turkish company who's been making equipment for over 60 years. Here at Access Machinery, being the authorized dealer, we have the full support here in our Vaughan office at location. So, I wanted to talk about something that sometimes gets tucked into the background. So we've talked with the machines before. I'm sure you've seen this model, great model, HDFS 3015 2 kilowatt. And you've seen brake press equipment as well, such as our servo brake or even our electric brake. But we know one thing that's not talked about enough is the software to support these machines and how they produce things. So today, that's why I have Alex Kimball today to talk about a special software called Metallics and the whole software suite. So Alex, would you mind explaining?
Sure. So, as Andrew mentioned, there's been a long time association with metallics. Started to look at this program about 1993 and been working with the program, and then about a decade after, our company developed a plugin for metallics for 3D software. Metallics generally was founded in about 1987 and has a leading CAD/CAM solution product called the CNC CAD, and a couple of other associated products like Metallics Bend, Metallics Robot. It supports a wide range of machinery, punch, laser, flame, combination of those. And its power solution have a quick creation of NC file and importing them directly into a CAM system and sends it into production. So CNC CAD is very user-friendly software and takes very little time to learn the software. And usually when you go and choose the software, you have to think about critical business aspects and what's your return on investment on the software. So we always say that why the software will bring the impact on the bottom line of any company. So one of the examples that strikes me when I think about the solution is basically one drawing solves all. You take one drawing and you go and process parts between different machines. You go send it to punch, go to send it to laser, then go straight send it to bending machine, and the software basically allows you to have one drawing support all the machines. One other critical aspect of saving design time, it's about 30% of the design time when you use a direct link with the CAD systems. All the major CAD systems supported, which is SolidWorks, Solid Edge, Pro Engineer, now it's Creo software, and it basically allows you to import 3D geometry into the CAM system and avoid the critical DXF or DWG kind of file transfer, which basically save you from retooling, recreating the parts when you run the production. So it's very important and it saves a lot of time. And actually, if you look about your business and you wide range of machinery, Metallics supports about 900 plus post-processors. And so when you go and grow your business and you buy new machinery, program will support all the machines pretty much right out of the bat. So one other important aspect of the program and the company in general, the philosophy of the company is they add machines to the software, only those machines that actually running parts on the shop floor. So they never add machines from the catalog just for the sake of adding machines. So all these machines are punching parts, laser cutting parts somewhere in the world, and why those machines in the system. So again, I know the price-wise, the software is one of the most attractive prices on the market. There was a benchmark run with the other companies with about 30% cheaper on the software side. And it's basically a combination of the above advanced technology features makes it a very attractive proposition for the customers. And especially our strong partnership with Durma gives you a lot of advantages with integrated modules for laser, punching, and bending machines right off the bat, which probably you'll see later on in the presentation.
Thank you very much for the explanation, Alex. I mean, despite the price and all the features and all that, this software really packs a punch. I've been using this software a lot lately, and it's really helped me design parts that I can guarantee are going to work through the entire workflow. As Alex explained earlier, you can actually verify if these parts are even going to work on your equipment before you get to that stage, helping you quote better, helping you save time, and helping you save that critical time in your production. So without further ado, let's take a look at what the software can do and take you through the entire package. We start here with the module MBend. MBend is a part of the Metallic software suite. MBend, as you can guess by the name, controls the bending software, but it has powerful CAD abilities with 3D files. Here you can see some of the 3D files I have here already that I'm producing. You can get an example here and take a look at it and preview your files here. All the data, in this case from SolidWorks, is transferred to the MBend software. It already pulls our material type is already pulled, as it knows. Any errors would show up in the white field, so a clean white field is a good thing. You may also defer from the material if you wish to change it here, and also select a different machine. Today we're going to use our servo brick, which we've demonstrated before. And as you can see, I'm pointing over the bend table. You'll see in a moment that we can actually fix the 3D as well if the K factor wasn't correct in the software. We're now going to base it on the tooling, which is significantly more accurate. Here, you get a full 3D simulation of the machine. The software collects the bends for you. It determines what are down bends and what are up bends, and labels them as such. So we have to start with the tooling. With the tooling here, you can either select manually or let the software decide. The software does a great job of selecting the tooling for you. So here, I have a list of a bunch of tools I have in my shop right now, and you get a preview of what they are. So when you press the auto feature, it immediately selects what is the most suitable tooling, as you see with the green flags there, and gives you a preview of both. If you go to the red flag, you can also see what didn't work and the reason why. Maybe the radius was wrong, maybe there's a collision, maybe the flange is too small for that V size. In this case, I'm going to choose the final tool here because I like to go with a taller tool with a bit of a gooseneck on it. That's a personal preference, but either one of these tools would have worked. You get a simulation of what the tooling would look like, but we still have to sequence this part as well. As you can see, there's quite a few bends on this part, and when you go to the sequencing phase, that can take up most of your time. As most brake press operators would know, most of their time is spent sequencing properly because you don't know, especially when you're up to 12 bends, such as a part like this, you're not 100% certain what's going to collide or what becomes before that, making a lot of waste at first. I mean, brake press operators, depending on their skill level, could waste up to 3-4 setup parts, which are very common in the industry to just cut extra setup parts, wasting material and time, because you're not 100% certain if you can even bend this part or what direction is feasible first. So as the software thinks here, and it's totally dependent on the speed of your computer. I'm using a laptop here, but typically a desktop PC, as a designer or a programmer would have, would work through this solution much quicker. Many different solutions here as it works. I like to let the software give me a few options to choose from instead of just choosing the first one, but of course you could just choose the first option as well. In this case, for this demo, I will stop the production right here, and I will take the third solution. Once I've chosen the solution, I can get a pre-simulation of what the bends are going to look like according to the fingers and the tooling. This lets me check for any collisions even prior to the main simulation part. It also tells me how far the stations have to be from each other to collect these bends. As you can see, MBend has already collected multiple bends together to reduce time to having to hit one at a time. If it could do 2 bends in one station, the software is going to do that. Once you move on to the simulation stage, we actually get our station layouts now, which are optimized for each of the bends. So as you can see here, the software chose a larger tooling for the machine, so we can quicker bend, even doing the gapping perfectly. Finger positions and retracts are pre-programmed in here, and collisions are already been checked for. You can see with this tooling here and this finger position, I wasn't happy with that. I don't like to put a flange under the fingers, so I can just simply click and move the finger to a new position automatically. So now I can also check for any type of collisions here and see maybe how close the bend actually is. Because of simulation, I knew I could do this part. I would not have known that right away, knowing how close the tooling is, but here it's showing me that absolutely yes, this part is going to fit. It's a very close flange though. Now into the output stage here, we're getting ready for some production. So I can actually push our NC directly to our brake presses, so all the information's already there, saving plenty of setup time. Next, I will generate a report so I can bring this to the operator or have it on the on screen, depending which feature you like to choose, where each setup will be listed on the paper. It also gives you a visual representation for a part that's not so symmetrical like this. With the 3D representation, I can tell what direction everything needs to be. Let's take a look at the report. It gives you a full isometric of the part, the tooling layout, so you automatically have it there, you just follow the numbers, and tells you every single bend in order for your operator, reducing setup time and reducing waste. Now we're going to move on to CNC CAD directly from the software. It is automatically going to create a new flat and go into CNC CAD, which is our flat laser software, or if you have a combo machine or punch or flame cutting. The great part about taking it directly from MBend is that the bend deductions are perfectly correct. Regardless of what the 3D drawing was, it's always the tooling that decides the bend deduction. So now that we've told the machine what the exact radius and the tooling are, we have an extremely accurate part because the flat size has been adjusted. We now can make adjustments to lead-ins very quickly. We could even add micro joints to parts immediately. For example, these aw-browns might flip up, so I want to be safe here. I put a micro joint there, it automatically copies it to all the nearby contours. We now save this part and move on to the next suite here we call AutoNest, another part of the Metallic software. AutoNest, as you can guess by the name, automatically nests your parts onto a specific sheet, regardless if it's 1 or 50 parts, giving you quantities of each and putting them all in a nest for you. You'll see demonstrated here. We're going to make a nest of about 10 parts for this demonstration. It already collected the material for us, and that's going to be sent to the machine. So we already know what cutting parameters to use, be it lead-in length, turn speeds, or any kind of acceleration is automatically applied. Our parts will be collected on top. In this case, we have 1. I press the Auto Nest button. I have a sheet down there, 48 by 48. You can even track the quantity as well. I press run and we get a simulation of what the software is guessing for the best utilization on this sheet. Utilization is a large factor in cost analysis, and this software handles it perfectly, putting the parts as close together as possible without errors. Automatically nested. The auto cut has already been done by the software. I didn't have to manually add any cuts. I only had to manually change a few lead-ins if you so desire. Create the NC. As it generates the NC data, again, it's based on the speed of your computer. And we now move on to the simulation screen. where we can verify what it looks like. As you probably noticed as well, I didn't apply that fly cutting. We talked about fly cutting before in previous episodes. This software automatically applied the fly cutting, which saved us time on contours that are applicable for that. Now that the nest is complete, we can save that data, and we already have our NC data here done live right before your eyes. So bend and blank all done at once. All right, so I absolutely love this software. As you saw, the full software suite allows us to go from blank to bend and back and forth and completely control all of that. Is there any other features that I'm not aware of that I haven't demonstrated here? Because it's a quite featureful system we have here.
Yeah, one of the features that in the AutoNest, in the laser, you can also add probably common cutting as well.
Common cutting, yes. That's right.
So you can set up the right width of the beam and then just automatically create the common cuts to utilize material even more efficiently than it's shown.
That's a very good point for even better utilization if your parts are applicable for common cutting. That's a nice automatic feature to have as well.
One other option which is comes to mind is also opportunity to create some cam layers as well. So I know we have done a presentation on laser machine, but on the punching side, you can predefine, let's say 0 and 90 degrees rotation of the part. And then if your machine has no auto index stations, you can basically pre-program the tooling this way that when you turn parts 90 degrees in AutoNest, then your tool's automatically selected. So you don't need to deal with choosing the different auto index stations and so on and so on. So that's one of the other features that you can also.
Another time saver right there. So yeah, as you can see, it's a full package. It's not just for laser and brake press. It expands capabilities even beyond that, being a full blank to bend solution integrated into one type of software. One thing I also you've seen too is that a lot of engineers like to work with 3D, of course. It's much more beneficial. But of course, you can bring 2Ds right into MBend and collect your bends from that as well. And you could even etch your bend lines onto the part. So there's many features you see here. That was just a little teaser of how many features this software has. And a teaser being 10 minutes, that just goes to show how much the software suite has together. If you want to know more about the software or get a more in-depth demonstration, please give us a call at Access Machinery. You know me, Andrew Vicente, and I will absolutely demonstrate more of these features that even Alex explained as well. That's absolutely. So the next part, let's take a look at what the laser does with this part. Now that we've nested it and shown the software, let's go to the laser side and see what she did for the laser. So I apologize, I meant the brake press here. So we're going on to the brake press first. And we have our blank parts here as well. We've seen this machine before. This is our servo brake here. On our servo brake, as you can see, we have an automatic or hydraulic tooling system, so we can put our tools in very easily. We got our 4-axis back gauge system on this one, independent axes. We have the R up and down, and the Z1, Z2, and the X. So we got our blank part here, and we can bend it like this. Because of that MBend program, I didn't really have to do very much here. The finger positions were correct, the tooling positions were correct, so I just had to push it against the backstops. I also have the report beside me, so I know exactly what bend needs to be next, which way these flanges need to face, and anything like that. So because of these bends here, even the retract is done. I might have clipped that part there because I have a flange sticking out. The retract was automatically programmed in the software, so I didn't have to think about that. This truly was completely simulated beforehand, and it's proving how powerful this is. Even on this box right here, the tooling size was decided and says it has to be this size to fit between those two flanges. Moving on to this final complicated bend here. This is the one we were worried about, if the flange was going to touch the edge or if the tooling was going to touch the edge of the box. Again, because we've simulated this part here, we know that we're not going to have an issue. You can see the safety light barriers for the box mode. Just hesitation just to keep you safe. That's a good looking part there. Perfect. So things are a bit out of order, but the point is that I went from bend, from the software to bending, and we can do the blanking next as well. But I wanted to talk a bit more about the bending as well, because I've noticed that there's a large library of supported tools. So even if you want to put your own custom tools, you can do anything like that. And what's great too is that even if you have a 2D reference of it, a completely custom tool you decided to make inside house, you can put that and extrude it to the bed length, and you have your tool, and the software will still simulate collisions, will still decide the V size, and you can still use auto tooling. Otherwise, you can use a library of, we've talked about mate tooling before, in this case we used Willa as well. All that tooling can be automatically applied from a factory database, even with your segmentations. So even if you have multiple machines, you know what tooling is being used up on all your machines, you know where you can put them, anything like that. So it really, really organizes you on the bending side. Perfect. So now I will put things back in order, and we're going to look at the laser, as I said before, because we went to the blanking part. So, of course, I said with the blanking, now our blank size is so correct. That's how we get such a tight bend on these parts, and that's we're going to take a look at in just a moment, how the accuracy of the laser, the accuracy of the software, and the accuracy of the brake press will produce a perfect part that is very tight, especially on this part where we're completely enclosing a box. I made the gaps very, very small, 0.5 millimeter, and I was able to completely close this box perfectly. Let's take a look at the laser for real now.
Simulate across the screen and take a look at our nest. Again, this was all done with the auto cut feature in CNC CAD, so it was already decided how it should look and how it should cut. Even the processing order, even that fly cutting right here, it was not a manual process. I simply pressed auto cut, as you saw, and it produced this part. Based on the parameters, of course, you can change what happens here. You can even have micro joints automatically, but for demonstration purposes, I wanted to show that. CNC CAD works based on a set of rules. These rules will help speed up your production, because you can bring, again, as I said before, 50 parts at once together and have all the rules taken care of for you. So you know what tips, you can micro joint it, or you know what's going to fall through, no micro joints. Pathing and acceleration is already decided by the software as the laser comes around. Here we are cutting 1 millimeter steel, or 20 gauge, or 36 thou, depending which way you want to say it. On steel, we cut it about 19,000 millimeters per minute, or we can say about 780 inches per minute. Again, this is being a 2 kilowatt machine. We can go even faster with higher kilowatts. However, 750 to 780 inches per minute is plenty fast for these parts. Again, with the order here, as you can see, we're not jumping around the sheet here too much. It actually automatically orders things for you, puts the part right beside it, and continues in order. Continuing across the cuts here, we got more fly cutting, all pre-applied again. The axis system of this laser system makes it possible to do this. Instant piercing again. We don't have to have the head travel here. As you can see, the head travel, we call it a ping pong movement or low head travel, depending which way you want to look at it. Again, this was decided by rules in the software. If you had a contour that was larger, we could absolutely change it to make the head fully retracted, get out of the way from that tilting contour, and move over across the sheet. Depending on your layout of the sheet, many things can be changed through the software and applied automatically to give you the best experience on laser and minimize collisions. Maintaining the standoff here, of course, is their Pressatech Pro Cutter head on this machine, monitoring the system the entire time. That's what you can see by the 4 LEDs. It's monitoring the condition of the head. You can even connect to the head via Bluetooth, and you have an app to even monitor features even further, such as temperature, gas flow, and see if all parameters are stable on this head. Coupled with the IPG resonator, 2 kilowatt. You have a very nice machine here. We've shown this one before, and it continues to amaze me. Finishing up with our final cut here. Perfect. For this demonstration, we did half the nest here to show you. Look at that part. It looks great.
All right, so that showed a full demonstration of full blank to bend, or in this case we did bend to blank, but either way, the flow is regardless the same. Of course you would cut the part and then bend it first, but what's nice too is that you can even verify it. So if we were to maybe do a first off anyways, we could verify, but because of the software, it's already verified for us. We don't have to waste time with the waste, the first offs and all that. We can guarantee and be rest assured. I have an example here of this part, and I showed before. This is what I was saying about the half-inch gap here. So we have a part like this. This is completely enclosed. I'm holding it right here, and you can see how tight this part is. It's just amazing that you were able to design this, simulate it, and see the full experience of this part right here. And you can take a look at this, Alex. Isn't that amazing? That's what metallic software allows us to do. Do a full simulated production of a very, very tight tolerance part. All right, so I'm very excited that I could have you here to explain more about the metallic software. I'm very excited about it. So what would it take to get this software? What would I have to do if I was a shop and I'm very interested in the whole software suite? What would be the process?
Process just to we usually go through verification process. We understand what the company wants, what exactly they're trying to accomplish, and then basically go through a live demonstration of the software with the equipment on the company parts, and then basically setup takes very little time with a library of tools already incorporated, and should be easy walk through. So,
I like that word easy. I'm hearing that a lot today with metallic software. That's great. Thank you for that. So yeah, absolutely, we can do a verification for you as well. I mean, I've already proved out one point right here as well. It looks great. And so I'm very excited to use metallic software and continue to use that. So thank you very much for helping me out with that and demonstrating the software to me. I'm going to be continuing to use the software to make all kinds of parts, and all the future parts you see in the live stream, I guarantee will be built through metallic software. All right, I think it's about time for questions. So let's take a look at some questions we got here. Perfect. Oh, we got plenty. I love this. Okay. Well, the first one's a compliment. I just like that right off the bat. That's perfect. Incredible machines. Performance and reliability are top notch. I agree. Very much. All right, so what is the range of thickness for the plates? Range of thickness for the plates is for cutting. When we talk about cutting, we're going to say based on the kilowatt of your machine or whether or not it has a zoom head. I can give you a full chart and full breakdown, but I mean, we offer machines right up to 12 kilowatts with a zoom head, and we can go beyond 1 inch if that is necessary, but it depends on the machine, of course. It really depends on the kilowatts. I'd love to go in more detail with that, and I can give you charts and show you what could be done there. You're talking about for this showcase? This showcase, again, this was 1 millimeter steel. Yes. Why would you recommend metallics versus other CAD/CAM? Alex, please.
when I think about the software recommendations, you always need to think about the value for the money. So what you get when you pay the price for the software, what you get, what kind of features you get, how many features you get, and how it improves your pretty much bottom line. And the software should be very easy to use. You don't need to have very powerful machines to run the software. And also, one of the critical aspects of the software is the technical support. So when you have an issue, how you can get technical support people to answer the questions, how you can get technical support people to help you out. So in, for example, in metallic software, in CNC CAD, there is support built in right inside the software. So basically, by click of a button, you can send the report to head office, and technical support team will get a collection of all your files, all your machine settings, your CAD files, your tooling, everything else from the software, and they will restore pretty much your environment. And so customer doesn't need to call technical support, spend time on the phone explaining what the issue is, and then basically they right away understand what is really happening and then reply back within pretty much 24 hours to 48 hours answer.
I can vouch for that, by the way, because I had a little case study, or a little own case study here. We had a customer having an issue with the software not quite doing what it wants. It was having some issues with crashing. I was able to contact Alex. I had a response very quickly. We gave it to the customer. They were super happy. Things were solved very quickly. And even my help here, even to help set up the Metallic software for me, everybody's very, very responsive at Metallics, and I'm very thankful for that, and I can absolutely vouch for their support network. And being built right into the software, they know immediately what the issue is, so we can help you remotely very quickly. I appreciate that. All right, we got other questions here? All right, perfect. Thanks for the last question, Mark. I appreciate that. All right, so I think that about wraps it up for Blank to Bend. Again, if you want more information on what we've done here, or how to do this, or how do you integrate it into your own shop, please contact us at Access Machinery. We would love to help you integrate it with all your machines, and even some of your existing equipment as well. We absolutely love to do that, and anything you saw here today, these are real demonstrations, real parts, real possibilities. Thank you very much for watching.